Get started. I know, we should have a 3-day deep dive. How about that? We could spend 3 solid days talking about microservices on a Q&A only. Wouldn't that be just like the best session ever? I've got no materials. Just fire off a question. Let's talk about it. Next question. Let's talk about it. I would love to do that. Maybe next year I will do a workshop like that. That sounds like a blast. I'll have to talk to Dilip about that. Okay. We are going until, how long? Let me get the schedule up here. We have until 12:45. Cool. That's not nearly enough time. Okay, good, 12:45. All right. I'm gonna go fast on this next section just because we're gonna dive deeper into it, but it's kind of important still to get just the context of an API layer. When we talk about an API, we kind of throw around this general term, API. Well, let's actually kind of at a high level define it. I'm gonna show you 3 implementations of an API. But the API really is meant to actually hide the endpoint. The original microservices pattern, when it was coined by Martin Fowler and James Lewis, kind of did define this application programming interface, this API layer, just as a proxy. And really it's just meant to expose what's made available for public consumption. Well, isn't it interesting? You do not need an API for microservices. You don't. Because every microservice itself already has some sort of web server built into that Docker image or that container. And that's how it itself exposes those RESTful endpoints. So we don't need an API because each microservice already has Tomcat or Jetty or Nginx or whatever built into it. But it's a really good idea to provide this next level of abstraction, this API. Because in this prior image right here, what's made available for public consumption? The answer? Everything. Everything. What about private services? That's a logging service, and that's a security service. Everything is made available. And so this allows us to really hide services that really we can experiment with them, that they may be infrastructure services, etc. One of the things I would encourage you from the very, very start of your project is to do what's called federate the API. In other words, domain scope it. This is our API for shipping. This is our API for customer. This is our API for tracking. This is our policy API. This is our issuer API. Here's our quoting API. Here's our DDA API. Here's our SAV for savings API. Those sort of things. Whatever your domain happens to be, to start federating these. And that's for 2 reasons. One, it avoids the single point of failure and performance bottlenecks that you will experience with these. And number 2, it domain scopes those endpoints. In microservices, generally, you have what are called service owners. Now, a service owner is usually an architect because they cross different teams. But let's use this auditorium and personify it to use as an example. And so the point is, this is our customer domain. This is our order domain, the whole order management and stuff. And this is our shipping domain. This is how we ship products. And so we've got customer information, our customer management. We've got all of our order management, and we've got our shipping and warehousing. 3 different domains. If that's our company, generally I'm going to have 3 service owners. Like I'm the service owner, for example, for customer on a client. And so the point is all the teams here, let's say there's 4 or 5 teams, I would be the service owner there. Maybe Manoj is the service owner over here for this group of services, for example, and shipping. And so the point is we would have our own API. We would manage our own endpoints. We would manage our own documentation for all the functionality for customer. And so generally, I move these APIs towards those kind of domains. If we have multiple customer domains, I'm going to have multiple customer APIs. And so that's just a very smart thing to do from the very, very start. Why? Because it's hard to start splitting these apart if you get to the point where they get too big. Okay. And so the point is this. When you do convert an application, and I'll put it in quotes, a website or some sort of user interface that has functionality that goes out to a database, you really don't need an API because the only single thing calling those services is, in fact, a monolithic user interface. However, I usually add an API here when we want to start exposing those services to the outside world. In other words, to what's called an ecosystem. It's a very common term when we talk about microservices to talk about an ecosystem, and that's the grouping, the logical domain grouping of services. So this building, this whole auditorium here, is our ecosystem. We have 211 people here. That means we've got 211 services in our ecosystem. But 40 of those services are bound to an application context called shipping. Another 80 are bound to the order management. And the other 61 are now bound here to customer management functionality. And so that's kind of the verb, just the names, the nomenclature. Okay, so let's take a look at 3 types of APIs that you may have. And like I said, hold off on the questions on the API piece because we're going to go really deep after lunch on APIs. But this is just to really say there's 3 types. The first is an endpoint proxy. Somebody had asked about reverse proxies and stuff like that. I'm going to talk about those in a little more detail, but the reverse proxy, that essentially is what this API is. And so again, any of these things, Nginx, IIS, any of these are the implementation. It's just another layer of indirection in front of all the services.
Mark.
One second. Yep. So the question is it just the external services that use this or the internal? Boy, that's what I'm going to show you in the communication patterns. It's both, unfortunately, and that's a problem. Yeah, that's yet another pitfall that we end up having. So yeah, the point is when we say this API layer, we really want it for public. But I'm going to show you the problem on part 4 when we get to what if we use REST? How do we communicate between services? How do I communicate with Manoj? Well, I have to go through the API. But yeah, I'm going to talk about that and all the permutations and how to solve that when we get to service communication. There was another question I did
Mark,
here.
Mark here. Yeah.
Where's your hand? Oh, there you are. Okay.
Yeah. So when we split this, as you talked about, like domain-centric grouping of these in the API layer. So in most scenarios, there is a need for microservices talking to other domain services.
Right.
So in terms of, rather than talking to the microservices in between these layers, like a customer complaint, for instance, would require a refund, right?
Yep.
Which might be a payments domain.
Yep.
So in those cases, is that right in terms of responsibility and in terms of data perspective,
Sure.
Right? Isolation point of view.
Absolutely. Absolutely. As a matter of fact, let me show you what I'm going to show you. Let me show you what I'm going to show you in part 4, just to be clear about this, this question. And to your point, absolutely. If we've got all these domains, let me show you how it actually works. It actually looks like this, and then we're going to come back to this, but this is the communication section. What happens is, if this wish list needs to get the name, so here's my customer wish list, and here's the customer demographics, the profile. It has the name. I need the name. I only have the ID. How do I talk to it? Watch this. I actually go around through the gateways to get to it. Absolutely. And so to your point, your question, if I'm over here, a service here, and customer needs to get the customer orders or find out how many orders I have pending. A very good request because I'm in a customer area here. In that case, when I call out, I'm going to call to this. Let's say the front row of each of these are the API layer. And so what you're going to do, Vishal. So Vishal, what you're going to do is you're going to actually call out to this API right here, which is going to front that microservice over here. Yeah, so that's very, very common. Yes, this cross-domain, absolutely. But yeah, that's how it really is kind of working. So to get to your point, this is going to be a problem, isn't it? Yes, and I'm going to show you how to fix that problem, but I'm going to describe that problem in part 4. So anyways, let's see the other two. Let's see the other two forms, because the first is just a simple proxy. that I just described there. My favorite out of these happens to be, as a web server, does happen to be Nginx. It is actually the most popular, I believe, still Docker image download. But it does provide load balancing. That's why I like it so much. So it already provides load balancing capability. So it has a little bit of an extra edge over the other proxies at that point. However, speaking of load balancing, this API could in fact be a load balancer. I could use something like Traffic, or I can use Barracuda, NetScaler F5s, and that could actually act as my API to actually go through the load balancer. However, these two kinds of proxies work well for simply just hiding your endpoints. But how do I do security? How do I do the cross-cutting concerns that this gentleman was asking about? All those pieces. That I need programming code. For that, I would use a gateway. Now, isn't it interesting? With a gateway, this is a piece of code. And so, in other words, I could use Mule, I can use Camel, I can use Spring Integration, I can use Shuttle, I can use anything from BizTalk or CA or any of these. And you might think, or I could do these custom. A lot of companies write their own custom gateways, pieces of code. And you might think, well, Mark, those are all ESBs. That is correct. The implementation of a gateway, if you use a product, is usually the same implementation as an ESB. But the important point that we're going to dive deep into in part 4 is going to be the role it plays. The capabilities are different. In SOA, I would use Mule or Shuttle in .NET or Spring Integration. I would use these integration hubs or ESBs. I like to call them integration hubs, but whatever term, ESB, integration hub, it's the same thing. I would use these integration hubs to be able to do protocol agnostic heterogeneous interoperability. I want to call Visual right here. Visual's an EJB using RMI over IIOP. I happen to be a .NET client using ASP, and I'm going to call SOAP. How in the world can I get to Visual an ESB? Because it does protocol transformation. How do I communicate to a C++ application sitting in Tuxedo using ATMI, which Tuxedo's native protocol, and I happen to be using .NET Remoting? Same thing, an ESB. However, that's a capability that's not here in a gateway, and I'll show you why when we get to that point. All right, it's not uncommon, as I kind of showed in that other slide, to have a proxy, a simple endpoint proxy that is fronted by a gateway that allows us to actually write code to do security, to do log ID extraction, to do request ID generation, auditing, metrics, all this. And it's not uncommon to front those gateways with load balancers, especially across multiple data centers. It's not uncommon to have all 3 layers in our ecosystem. Matter of fact, we may have multiple load balancing capabilities if we're really distributing our infrastructure. And so again, this is just a little high-level view of the types of APIs, so that when we say API, what I really mean is it could be a proxy, it could be a gateway. It doesn't matter at this point. Okay? So let's do a timeout, because I really want to go deep on especially the gateways and the use of those. And let me give you a hint. Here's my statement. In microservices, and this is my experience, you will need a gateway. You will. Now, whether that's implemented through a service mesh, same thing. Not same thing. The capabilities. You will need either a service mesh or a gateway. But here's the tip. Please don't leverage it. And I'll show you what I mean on part 4. Okay, so it's about the role. All right, let's get now on to part 2, which really I want to talk about the hybrids that exist for microservices, and then how to actually get to microservices, and that should take us right to about lunch. Okay, so 3 questions for you. Can you take, and this is microservices, this is what we've been talking about for a couple hours. Can you take your existing monolithic n-tiered layered architecture, your banking application, your shipping application, your customer management system, whatever your monolith is, and can you break that application up into several hundred or several thousand independent moving parts? No. You know, maybe a couple, but certainly not hundreds to thousands. They're all going to interconnect. Okay, that's question one. Question two, in your existing environment right now, how you deploy software and release software, can you manage the parallel testing, release, and monitoring of several thousand applications? You know, when I ask this question, I usually get, I get a laugh. That's a good one, Mark. Yeah, we can't even get one application out the door correctly. No, 1,000? No. 100? No. 20? No. We can't even get one out right. But then, the very last question, can you take your existing 4 terabyte Oracle rack relational database cluster and split it up into 2,000 schemas? You know, there, the laughter never does stop. Yeah, terrible. Are there any, see, I have to refrain from jokes. What do you think? Should I refrain from jokes? Good, okay. Are there any DBAs here? Any DBAs? No DBAs? Forgive me if I don't know the culture enough, but I love this joke. So since there's no DBAs, I'll ask this. Do you know the difference between a DBA and a terrorist? You can negotiate with a terrorist. Of course we can't split up our application or our database. You're not going to touch that thing. Rats, you know, we can split up our application into 1,000 different pieces. Yeah, we've got the environment where we can actually deploy, hot deploy. We've got good DevOps. But you know, this last question here is usually what nails it. We can't move to microservices. Yeah, those DBAs. All right, so, but usually, all jokes aside, there's usually good reasons why DBAs say, nope, you're not touching my database. Other people are using it. Other applications use that database. It's not only yours. You can't start breaking apart schemas. And so sometimes there are justifications for the fact that this is not feasible. All right, but you know what's interesting? That last piece, quite frankly, I'm actually going to show you a trick, a very complex trick, but I will show you a trick of how we can actually have thousands of microservices all sharing the same Oracle rack relational database, same schema. If you can't touch your database, then I will actually show you a possible way to overcome that. Okay? But I'm going to wait till part 4 to actually show you that. That'll keep you all here. Yeah, rats. I was going to transfer over to Scott's workshop, but I guess now I'm going to have to stay. Yeah. All right. So anyways, So what we have is a hybrid of microservices called service-based architecture, an extremely popular architecture style, perhaps one of my favorites. Now here, notice we've got client requests that actually come into a user interface layer. There's no API here. There's a user interface layer. We could add an API, but it's not part of necessary, I'll say at this point, because we could split this UI up right here, but these are separately deployed units of software here. These are services, but rather than microservices, these are portions of the application. We are a big, monolithic retail application. We sell products. Well, what do? Well, people have to order products, we have to fulfill those, and we have to ship them. Okay, well there's 3 parts of the application. Order placement, order shipment, order fulfillment, and order shipment. Those are 3 chunks of the application. You know, if you ask yourself, and do this exercise mentally, or just do it on paper if you want to, say, what does my application do? You can usually divide it up into about 6 or 7 pieces. That's what this is. These are all separately deployed, all sharing the same database. So here's what we're going to do. We're going to start with microservices because that's what we're all excited about. But the question up here from this morning, when should you not use microservices? When should we run away? When the complexity overwhelms us? When we can't do, a lot of hands here for my keynote that you saw yesterday. When we can't do that organizational change that's required? That's going to be a mitigating factor. When we can't split the database up, when we don't have DevOps, these are all places where it's not going to work. But can we still kind of sort of use microservices? Absolutely. Let's start with this, but we're going to vary three things. We're going to vary the service granularity, the database scope, and the way we deploy software. And let's take a look first at this service granularity. And because when we have microservices, these are fine-grained single purpose. We already looked at cohesion, and I'm glad I used that slide first, because now we really have an idea of, oh yeah, so it's like demographics and notification. You know, it's very high levels of cohesion. So when we have microservices necessarily, we've got hundreds to thousands. You might not think, and this is interesting, a lot of clients say, no, we foresee about 40. And by the time we're done identifying services after a couple weeks, we're usually into the hundreds. You'll see. It's amazing how fast services start popping up. So anyways, but with service-based architecture, these are portions of the application. How many services should we have, Mark? This time I can answer it. 6 to 12. A good average is around 7. That's a good number. That's a good number to shoot for. Maybe 6 to 7, maybe 8. Yeah, around that range. Because these are just chunks of the application, very coarse-grained services. Call them macro services if you want to. Thousands of classes here. This is our customer service. All our customer management is here. Here's our order management, very large, and here's our shipping functionality. 3 separate services. As a matter of fact, the advantages we get to do this are 3. First of all, I get much higher performance and much better robustness, because once I'm in the customer functionality here, I'm bouncing all around. I'm executing functionality and stuff like this. There's no inter-service communication. There's no latency. Hence, there's better reliability. And I get domain scoping for free. In other words, can you identify in your ecosystem, here's our ecosystem, all of the customer-related services? No. Oh. How many are customer? Which ones are customer? I don't know. I mean, they're kind of scattered around. You know, I knew we should have named our services customer underscore blah, 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 shipping underscore blah, 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 policy underscore blah, blah, blah. We don't think about these things. And plus, the names get really long in that case. Let me give you a hint, though, in microservices. This is what I do for this domain scoping. Naming things is too hard, and it's too inconsistent. I love to use identity annotations. That's what I call them. It's one line of Java code. But basically, it's an annotation that does nothing. It's simply an identity. And so, let's say that we have in our insurance application policy right here. And so you guys are going to be the policy domain. And so all the classes that front our microservice, our entry point, are going to have at the front of that class an annotation at policy underscore domain. This is our issuer, at issuer underscore domain, at customer underscore domain, at quoting underscore domain. And so this is one way of being able to identify what are all my quoting services. All I need to do is write some simple tooling to do a search and say, get every class that has at quote domain. And so that's a way to do that domain scoping. Something that if you're already not doing it, definitely a good practice. Yeah, because this domain scoping will hurt you eventually. But our trade-off, though, you know, Vishal here, who, remember, had those errors appearing? That was actually Vishal right here. Now, he found the problems to all those flameouts that we saw. As a microservice, well, who does he have to coordinate with? Himself. Who does he have to test? Himself. Who does he have to deploy? Himself. But now, this is our service right here, albeit it's not that bad. These are all the classes. You have to coordinate with all these other teams. You want to test. Vishal, you really should test everything here. And to deploy, you're ready, but you're not, and you're not even close yet. And you've already broken things because of a configuration. So we have to wait until you're ready. And so it slows all those things down. And so that's kind of the trade-off associated with that. But more powerful is this idea of the database scope, because we need that bounded context with microservices. However, with service-based, we get to share the same database. Why? It's about sheer numbers. We only have 6 to 12 services. that's feasible to manage database changes. As a matter of fact, I'm going to show you how to mitigate those, because the trade-off here is twofold: performance and feasibility. Once again, we get performance again. If we go to microservices and we're not even close to our SLAs, things are way too slow. One of the ways of it, I'm going to show you a couple of other ways, hard ways to address that. But one of the other ways is to start making your services more coarse-grained and share a database. Because now that's the second thing we've seen performance of. Why? Think about this. We've got a query. I'm just going to use relational database again. We've got a query, and it does joins. Well, you know, in microservices right here, if I've got a join to 6 different tables, guess what? I now have to take that SQL. Every one of those joins is a RESTful call to somebody here to get your data. And then I have to aggregate it to myself in programming code. This is what databases do really well, by the way, that now I have to do through programming code. Here, though, nothing changes with that SQL statement because I'm sharing the data. And so I get high performance. And besides, remember that DBA that we can't negotiate with? No. All right, just feasibility alone here. But the problem is, as you probably recognize, we're binding all of these services to a single database coupling. And so let's see how to mitigate that. So here, this is logical now. What we start doing, and this is what I'm going to try to show at the end of the class when we start talking about data. Take your database right here and start logically domain scoping it. In other words, these group of tables down here are our common tables. Now, when we think about, I got an idea. We're a monolith. Okay, so we're all classes sitting here. This is one big deployment unit, this entire auditorium. That's a big monolith. Okay, layered architecture. All you guys over here are all classes, but each of you are a class called an entity that represents a table in our database. Basic entities, right? Because when you guys do a query, we need to instantiate or inject these guys, don't we? Because when we do a query, these are the folks, these are the objects that are returning our data. Okay, make sense? All right. Let's all split up into service-based. And so this is service 1, service 2, and service 3, and service 4. Okay, so we have 4 services right here. Let me ask you this. What do we do with these guys? Ooh, we all, was that me? Oh boy. I will walk over this way. I see there's a line I cannot cross right here, isn't there? You didn't tell me about that. Get my heart going again. That scared me. Where was I? Oh yes. What do I do with what do we do with these guys? We all need to instantiate them. Put them in a jar file or DLL. Of course. So here's the problem. We'll call it model. Because in our monolith, we've just got one code base, and if you look at the IDE, this is just a package called model. And you guys are all the classes in that package called model. All of your classes map a table name. Instead, we do this. Watch, I can mitigate changes in this architecture. See these bottom tables here in the red? Those are common. And so what I'm going to do is take you guys here, that's common, and I'm going to create common underscore model.jar. All of us have it in our deployment script for build or whatever, for build or deploy. Okay. The next group of tables here are, let's say, for benefits. You know, this is a benefits application, so those are benefits. And the point is, that's your group. I'm going to create a benefit underscore model.jar. Well, who uses that? Just you guys right here. And on and on. So what I do is I start partitioning logically. Now, no DBA in the world can prevent you from doing this, by the way, because it's a logical partitioning, as fine-grained as you can, to be able to start, look at what I'm doing, splitting up those individual jars. This is like that advice I gave you about shared libraries and microservices. And so now, watch this. The magic here is as follows. Because once I've logically split my database to know which entities are in groups. You know, customer, here I have common, I've got benefits, here's the exchange to other state agencies, here's my customer model, the data entry model, so on and so forth. I need to make a breaking change to a table right over here. No, don't do that, wait. What table does that map to in the jar file? That's benefits underscore model. Well, who uses that? Just the benefits service. It's a way to mitigate those changes so that now this is the only service right here that I need to coordinate. And so it's a way of kind of mitigating those changes and stuff. But you know, I alluded to this yesterday in my keynote, that the best advantage here is the fact that with microservices, we know we have to use DevOps. Again, because it's not feasible to manage the parallel testing, release, and monitoring of several hundred to several thousand applications. It's just not possible. However, as I showed yesterday in the keynote, with Service-Based, nothing changes in your ecosystem. It's the same deployment pipeline you have now. And as a matter of fact, the two advantages I alluded to yesterday in terms of learning how to ride a horse, there's no DevOps needed, and there's no organizational change needed. We can organically start growing that. This is a huge advantage. This is pretty low cost, by the way. However, I really don't have an effective deployment pipeline. Those are the trade-offs. So it's important to understand there's a lot of benefits here, but I'm also getting some trade-offs. Okay. Yes? So the question is, how is this different from SOA? The problem with SOA, service-oriented architecture, is the fact that there is an actual pattern of architecture called SOA. However, what we've done is through products and kind of sometimes a misunderstanding or an overloading of the term, none of us really know what SOA really is. Service-oriented architecture in its pattern form is really all about heterogeneous integration of disparate systems. You know, I've got COBOL and Java and .NET and C# and C++, and I need to all integrate all that together. That's what SOA does. It provides us those ESBs so that I can actually abstract everything away so that I can call you with SOAP even though I have no idea what protocol you're listening on. I can change the contract and do contract decoupling through message enhancement. That's really where it's enterprise, more enterprise level. Now, I think I know the question, so that's my answer, but I'm going to answer your question, though, because a lot of times there's confusion. As a matter of fact, let me bring this up here, because it's a decent question because of the overloading of the term SOA. And so what we might say is, well, Mark, those are RESTful calls right here, right? Yep, that's a single deployed service. That's our customer management service. It has an API layer in front of it that has either RESTful or SOAP calls. And a lot of people call that SOA. And so in that particular case, it doesn't differ very much because this user interface is making RESTful calls into this service component right here, which has its own API of RESTful endpoints. This one has its own internal API. It could be external, but usually it's internal of API. I think that's what you're referring to, right? Yeah, so the pattern of service-oriented architecture really is all about abstraction. It's about heterogeneous integration of systems across the enterprise. It's about sharing of resources everywhere. This is really an application. That's where the difference occurs. But I can certainly see your point where this can start to go into a broken up user interface. We can put an API layer here, and all of these are RESTful endpoints. Yeah. So not much different in that sense. Oh, here we go. You can use the...
into a service component, then like what about transactionality? If you have like two-phase commits going on, how do you manage those?
Oh, yeah, absolutely. So the interesting thing is here, so that, you know, with the question about how do you do transactionality, it's the same database right here. And so that's why, notice what I don't have here is inter-service communication. And so the key point is when we start to use service-based, we carve out domains right here. Now, transactionality generally